Now, in order to graph a quadratic function, we're going to put together all the things we did in the last slide into one final part. So the first thing we do is calculate the coordinate of the vertex, and then you're going to plot the vertex on the graph. Then you would draw on the axis of symmetry through the vertex and determine the y-intercept and plot the y-intercept on the graph. Then you're going to plot the point corresponding to the y-intercept over the axis of symmetry and draw in your parabola, making sure that it's U-shaped. On this slide is a review of the formulas and steps to calculate the vertex, axis of symmetry, and y-intercept in case you forget any of the parts. In our first example, we have the equation y equals 2x squared plus 4x plus 3. Now first, let's identify a, b, and c. So we could say a equals 2, b equals 4, and c equals 3. Now, to determine the vertex, we first need to calculate the x-coordinate. So x equals negative b over 2a. So x equals negative times 4 over 2 times 2. If we simplify, you'll get x equals negative 4 over 4, which becomes x equals negative 1. Now if we plug this back into the original equation, so y equals 2 times x squared plus 4 times x plus 3, substituting the negative 1, if I plug that whole thing in, you get y equals 1. So this means the vertex has the ordered pair negative 1, comma 1, which you can plot on your graph. So you would go back 1 and up 1. Now we can draw in the axis of symmetry. Remember, the axis of symmetry is that vertical dotted line that goes through the vertex. So I can draw in the axis of symmetry, and your equation would be x equals negative 1. Now, the y-intercept is going to be 0, comma c. So since we know it's 0, comma c, in this case, our y-intercept is going to be 0, comma 3. So I plot that point. Now, the last thing we need to do is find the point corresponding. So if I know that I have a point on this side that's 1 unit away from the axis of symmetry, if I go over 1 unit on the other side, I can plot that point corresponding. The last thing you want to do is draw in your parabola. And you need to make sure it's U-shaped is the key thing here. So you're going to do the best you can to sketch the graph of your parabola. In our second example, we have the equation y equals negative x squared plus 6x minus 5. So in this case, this is really a negative 1. So we could say a equals negative 1, b equals 6, and c equals negative 5. Now if we want to calculate the vertex, the x-coordinate is negative b over 2a. This means it's x equals negative times 6 over 2 times negative 1. If we substitute and simplify, negative times 6 gives us negative 6, and 2 times negative 1 gives you negative 2. So negative 6 divided by negative 2 gives you x equals 3. Now if we plug back into the original equation, we have y equals negative times x squared plus 6 times x minus 5. And we're substituting that 3 for x. If I plug that whole thing in your calculator, you would get 4. So y equals 4. So the coordinate of the vertex is 3, 4, which we can now plot on the graph. Now the axis of symmetry is the vertical dotted line that goes through the vertex. So we can draw in that vertical dotted line. And we need to make sure we're doing this because if we forget to do this, it tends to cause a lot of errors. So it means x equals 3. Now the y-intercept is always 0, c. So in this case, your y-intercept is 0, -5. So I can plot the point on the graph. Now, if I want to find the point on the other side, I move over 1, 2, 3 boxes to the right, and move over 3 more boxes on the other side to get your corresponding point. The last thing we do is draw in that U-shaped graph. So do the best you can to make it as U-shaped as possible, and add your arrows at the end.